Hello students, in the previous session we discussed about the trigonometric identities and how to use them in the problems. Today we shall study about trigonometric equations. An equation involving trigonometric functions of an unknown real number is called a trigonometric equation. For example, cos x is equal to 1 upon 2, cos x is equal to sin 2x, etc. A solution of trigonometric equation is a value of unknown that satisfies the equation. Since all trigonometric functions are periodic, usually the trigonometric equations have unlimited number of solutions. The solution lying between 0 to 2 pi, that is 0 less than or equal to x less than or equal to 2 pi is called principal solution. The solution generalized by means of periodicity is called a general solution. The expression involving integer n, which gives all solutions of a trigonometric equation, is called the general solution. Now students, let us see how we can solve equations like sin x is equal to 0, cos x is equal to 0 and tan x is equal to 0. Let us take up the first one, sin of x is equal to 0. We know that sin x is 0 when x is equal to 0, pi, 2 pi, 3 pi and so on, or when x is equal to minus pi, minus 2 pi, minus 3 pi and so on. Thus, x is equal to 0. This implies x is equal to n pi, where n belongs to I, that is integers. Similarly, for cos of x is equal to 0, when x is equal to 0, pi upon 2, 3 pi upon 2, 5 pi upon 2 and so on, or when x is not equal to minus pi upon 2, minus 3 pi upon 2, minus 5 pi upon 2 and so on. Thus, cos x is equal to 0 when x is an odd multiple of pi upon 2. Hence, cos x is equal to 0, that implies x is equal to 2n plus 1 into pi upon 2, wherever n belongs to integers I. Now, for tan x is equal to 0, when x is equal to 0, plus or minus pi or plus or minus 2 pi, tan x is 0. This implies that x is equal to n pi, wherever n belongs to integers I. Now students, let us solve some theorems involving trigonometric equations. For the first one, for any real numbers x and y, sin x is equal to sin y implies x is equal to n pi plus minus 1 raised to n into y, where n belongs to integers. Now for the proof, if sin x is equal to sin y, then sin of x minus sin of y is equal to 0, or 2 cos x plus y by 2 into sin x minus y upon 2 is equal to 0, which gives cos of x plus y by 2 is equal to 0, or sin of x minus y upon 2 is equal to 0. Therefore, x plus y upon 2 is equal to 2n plus 1 into pi by 2, or x minus y upon 2 is equal to n pi, where n belongs to z, that is x is equal to 2n plus 1 into pi minus y, or x is equal to 2n pi plus y, where n belongs to integer z. Hence, x is equal to 2n plus 1 into pi plus minus 1 raised to 2n plus 1 into y, or x is equal to 2n pi plus minus 1 raised to 2n into y, where n belongs to integer z. Combining these two results, we get x is equal to n pi plus minus 1 raised to n into y, where n belongs to integer z. Here we have one more interesting theorem. For any real numbers x and y, cos of x is equal to cos of y implies x is equal to 2n pi plus or minus y, where n belongs to z. Let us see the proof. If cos x is equal to cos y, then cos x minus cos y is equal to 0, that is minus 2 sin x plus y upon 2 into sin x minus y upon 2 is equal to 0. Thus, sin of x plus y upon 2 is equal to 0 or sin of x minus y upon 2 is equal to 0. Therefore, x plus y upon 2 is equal to n pi or x minus y upon 2 is equal to n pi, where n belongs to z. That is, either x is equal to 2n pi minus y or x is equal to 2n pi plus y, where n belongs to z. Hence, x is equal to 2n pi plus or minus y, where n belongs to z. In this theorem, prove that if x and y are not odd multiples of pi by 2, then tan of x is equal to tan of y implies x is equal to n pi plus y, where n belongs to z. In the proof, if tan x is equal to tan y, then we could write sin x cos y minus cos x sin y upon cos x cos y is equal to 0, which gives sin of x minus y is equal to 0. Therefore, x minus y is equal to n pi, that is x is equal to n pi plus y, where n belongs to z. The following examples will be helpful in solving trigonometric equations. In first example, find the principal solution of the equation sin x is equal to root 3 upon 2. We know that sin pi upon 3 is equal to root 3 upon 2 and sin 2 pi upon 3 is equal to sin of pi minus pi upon 3, that is sin pi upon 3 and root 3 upon 2. Therefore, principal solution are x is equal to pi upon 3 and 2 pi upon 3. Let us take one more example to find the principal solutions of the equation tan x is equal to minus 1 upon root 3. We know that tan pi upon 6 is equal to 1 upon root 3. Thus, tan pi minus pi upon 6 is equal to minus tan pi upon 6, that is equal to minus 1 upon root 3, and tan of 2 pi minus pi upon 6 can be written as minus tan pi upon 6, that is equal to minus 1 upon root 3. Thus, tan 5 pi upon 6 can be written as tan 11 pi upon 6, that is equal to minus 1 upon root 3. Therefore, principal solutions are 5 pi upon 6 and 11 pi upon 6. In this example, we will find both the principal and the general solutions of the equation sin x is equal to minus 1 upon 2. For the principal solution, we have sin x is equal to minus 1 upon 2, which can be written as minus sin pi upon 6, that is equal to sin of pi plus pi upon 6 or sin of 2 pi minus pi upon 6, which again can be simplified as sin 7 pi upon 6 or sin 11 pi upon 6. Hence, x is equal to 7 pi upon 6 or 11 pi upon 6. Now, for the general solution, we have sin x is equal to minus 1 upon 2, which could be expressed as minus sin pi upon 6. This can be written as sin of pi plus pi upon 6. On simplification, this can be written as sin 7 pi upon 6. Therefore, sin x is equal to sin of 7 pi upon 6. This implies x is equal to n pi plus minus 1 raised to n 7 pi upon 6, where n belongs to integers. There is one more interesting example. Find the general solution for the following equation: cos 4x is equal to cos 2x. Here cos 4x is equal to cos 2x, therefore, 4x can be written as 2n pi plus or minus 2x where n belongs to z, or 2x is equal to n pi plus or minus x where n belongs to z, or x is equal to n pi or x is equal to n pi upon 3 where n belongs to z. Further, we note that the solutions x is equal to n pi, that is x is equal to pi, 2 pi etc. are included in the solutions. X is equal to n pi upon 3 on taking n is equal to 3, 6 and so on. Hence, the solutions are x is equal to n pi upon 3 where n belongs to z. Here we have an interesting equation 2 cos square x plus 3 sin x is equal to 0. This can be rewritten as 2 into 1 minus sin square x plus 3 into sin x is equal to 0. We can see this is in the form of a quadratic equation 2 sin square x minus 3 sin x minus 2 is equal to 0. We can solve this by splitting of middle terms as 2 sin square x minus 4 sin x plus 1 sin x minus 2 is equal to 0. On taking 2 sin x common from the previous two expressions, sin x minus 2 plus 1 into sin x minus 2 is equal to 0. Thus, two factors are 2 sin x plus 1 into sin x minus 2 is equal to 0, which on simplification gives us sin x is equal to minus 1 upon 2 and sin x is equal to 2. But sin x is equal to 2 is not possible. Can you tell me why? It is because sin x lies between minus 1 and 1. Therefore, sin x is equal to minus 1 upon 2 or minus sin pi upon 6, which can be written as sin pi plus pi upon 6 or sin 7 pi upon 6. This implies x is equal to n pi plus minus 1 raised to n 7 pi upon 6 where n belongs to z. One more interesting trigonometric equation, sin 2x minus sin 4x plus sin 6x is equal to 0. The equation can be written as sin 6x plus sin 2x minus sin 4x is equal to 0 or 2 sin 4x cos 2x minus sin 4x is equal to 0, that is sin 4x into 2 cos 2x minus 1 is equal to 0. Therefore, either sin 4x is equal to 0 or cos 2x is equal to 1 upon 2. That is sin 4x is equal to 0 or cos 2x is equal to cos pi upon 3. Hence, 4x is equal to n pi or 2x is equal to 2 n pi plus or minus pi upon 3 where n belongs to z. That is x is equal to n pi upon 4 or x is equal to n pi plus or minus pi upon 6 where n belongs to z. So, students, there is an assignment for you. You may note down question number 1, solve tan theta plus sec theta is equal to root 3. Question number 2, solve the equation tan x plus tan 2x plus tan 3x is equal to tan x into tan 2x into tan 3x. So, students, in this session we studied about the trigonometric equations and various methods to solve these equations. Thank you.